How much of a green premium is necessary to produce carbon-neutral concrete? What do economically and ecologically sustainable cement business models look like? I'm Kata, grab a cup of coffee and let's talk about it. In this video, I'll break down cement demand, production, and climate impact. Cement production is responsible for about 10% of global emissions annually. 60% comes from the fundamental chemistry of the process itself, and 40% comes from the energy required to fuel the process. The only resource we use more than concrete is water. Like steel, cement has been around for millennia and is massively important for modern civilization. But we rarely ever think about it. The first variations of cement were used 12,000 years ago. That is 3 times longer compared to steel. Every year, 4.1 billion tons of cement are produced worldwide. China roughly yields 60% of global production and 50% of global consumption. Portland cement is the most widely used type of cement, suitable for all general types of concrete construction. While the process itself has not fundamentally changed, cement production has of course become more material and energy efficient. The cement production process starts at the mine site, where limestone and other raw materials are extracted. The raw materials are crushed and transported to the production site, where they are blended and the mineralogy is adjusted with the addition of corrective minerals. The raw materials, consisting of about 90% limestone, 7% clay or shale, and 3% corrective minerals like silicon, are blended, dried, and ground into a fine powder to produce a raw meal. The raw meal is homogenized in a silo before it is fed into the kiln. The subsequent kiln feed is fed into a preheater, followed by a precalciner and then a rotary kiln for the forming of Portland clinker at 1450 degrees centigrade. Steel and cement both have high emissions and require a green premium. Cement even more so than steel. To make cement climate neutral, we would have to pay about twice as much for cement. In comparison, for green steel, less than 20% green premium is sufficient. You need either regulations or premium pricing for those products. Premium pricing is unlikely, considering they're a true commodity with low price elasticity.
Clean cement is the same as regular cement. You're just changing the manufacturing process. But with climate, we have a deadline. We know we need a lot of innovation to get from 51 billion tons of emissions all the way to zero by 2050 to avoid a climate disaster.
From a technical point of view, there are 2 ways to reduce emissions: during production or through carbon capture. To reduce emissions during production, less material or less energy can be used. While zero-carbon alternatives seem expensive at face value, the initial premium becomes negligible when baked into the price of the end product. For instance, doubling cement's price tag to include the $100 per ton abatement cost only adds 0.3% to the construction cost. So the problem isn't that the premium is the de facto limiter, but rather how the cost is spread across the players in the supply chain. So let's have a look at what's going on in the market, and in particular, what kind of approaches are being taken these days to disrupt the status quo. In some cases, it took me a while to figure out what the companies are actually doing. It seems that some of them don't have really massive media coverage, which might be because it's not necessary to help the company progress, but perhaps in some cases also so that they don't reveal too much for the competition. Ecocem is an Irish company founded in 2000. It produces a range of low-carbon cements based on ground-granulated blast furnace slag at 4 plants in Ireland, the Netherlands and France.
Nous apportons continuellement de nombreux moyens dédiés à l'innovation avec pour objectif principal protéger l'environnement.
Ecocem received $22.5 million in funding from Breakthrough Energy Ventures, a fund backed by Bill Gates, Jeff Bezos, Jack Ma, and Richard Branson. Carbon-Build's process is implemented in the factories, where the masonry and precast concrete products are produced. It involves changes in both the concrete's formulation and its curing process. When you combine these two innovations, you end up with substantial changes in the cost structure without really changing the supply chain. Carbon-Build's technology uses carbonation reactions to remove carbon dioxide from the flue gas to turn it into a solid within the concrete. Carbon-Build products have at least 50% lower carbon footprint than conventional concrete. Up to half of its reduction comes from the utilization of carbon dioxide in the flue gas, while the rest comes from the use of lower intensity materials. Carbon-Build's reversive technology uses a proprietary concrete mixture consisting solely of cost-readily available materials. The mixture is preformed using industry standard equipment. Carbon-Build enables a 15 to 20% reduction in raw materials cost, which alone can expand operating margins by more than 50%. On top of that, they're embedding substantial amounts of CO2 into the concrete during curing. This can deliver 50 to 80% reduction in embodied carbon with today's technology, while at the same time increasing profit margins of the customers. CarbonCure offers a solution for concrete manufacturers to recycle waste CO2 during concrete production.
CarbonCure is a technology company helping concrete producers transition into the new low-carbon economy. We developed a technology that bolts on to an existing concrete plant. We're starting with a greenhouse gas, a harmful waste product, and we're turning that into value. We add a small amount of CO2 to react with the chemistry from cement that allows you to create a higher strength concrete. Carbon utilization is not just some abstract idea. It's not just happening in the lab. It's happening in the real world.
Their technology injects CO2 during the concrete mixing process. This spurs a chemical reaction that permanently mineralizes CO2 within the concrete. What's interesting is that adding CO2 also makes the concrete stronger. This enables the concrete producer to use less cement, which unlocks further decarbonization and economic benefits. Solidia offers precast concrete manufacturers a technology that, together with proprietary concrete mix design and a specialized concrete curing process utilizing CO2, can reduce the carbon footprint of up to 70% compared to traditional ordinary Portland cement systems.
When you make Solidia cement, we are cutting the CO2 emissions at least by 30%. And when we cure Solidia cement, when we make the concrete, we add an additional 20–30% of CO2. We consume it during curing. So this adds up to 50–60%, and depending on the formulations, our CO2 savings can go up to 70%.
That's it for now on cement demand, production, and climate impact. I wanted to sincerely thank each and every one of you for subscribing, hitting the like button, and leaving a comment below. I think we had really fruitful discussions on this channel that help people to understand the subject better, learn something new, or even grow as a person. And I think this is what this channel hopefully is, or at least should be about. Thank you very much for watching. Let me know your thoughts and see you in the next one. Bye.